Close. I get much closer.
All right, everyone, I'd like to thank you on behalf of Champion Drive and Purina for joining us tonight for the Purina Dwarfism Symposium. A big thanks to Clay Elliott and the folks at Purina for allowing us to have this on championdrive.com. And thanks to Dr. Fitch, Dr. Hagen, and Darren Hanningshot for their work on this as well. Just a few general items before we get started. This will be available to watch and view after the live session is over. We've had several folks ask if it will be available, and it will be available on championdrive.com shortly after the completion of it. In addition, there have been some issues with YouTube Live today. So if you're not able to join in, rest assured the entire presentation will be available here shortly. We've also had several of you submit questions leading up to this that you'd like to have answered. We won't be able to get to all of them, but some of these will be addressed tonight. In addition, Purina will be holding a second part to this symposium at Sedalia at the Midwest Stud Ram Sale, which will include a live phenotypic evaluation of yearling ewes that are FF, FD, and DD. More information on that will be forthcoming. And below the live feed, we'll have a live chat window there, hopefully, which you can ask questions and comments. This chat is moderated, so please have appropriate questions only, as we have viewers of all ages on tonight. Thanks again for joining us, and without further ado, we'll turn it over to Dr. Fitch.
Are we good to go? Okay.
Yep, go ahead.
I'm going to basically start off. I'm Dr. Jerry Fitch. To my left is Darren Hanningshot, and to his left is Dr. Darren Hagen. We're going to basically, Darren Hanningshot's going to start this off and bring it to you as far as how we got started and what we started when we started looking for this gene, and we'll just go down that path from there. On you, Darren.
So roughly 18 months ago, I had received a few calls from producers, breeders, buyers, several different people from all walks of life that just in general conversation had asked me if I knew anything about dwarfism in sheep. And I, asked a few more probing questions as far as, well, what exactly do you mean? What type are you actually referring to? And then what actually got the ball rolling is one specific person actually, again, called me and had bought a sheep that he was quite proud of. And 2 months later, he wasn't quite so proud of him. And that's neither here nor there in this discussion, but that's what actually got the ball rolling down the hill. So I had seen enough of these sheep. I judged enough shows around the country that I had noticed that, yeah, there were little ones, and whether or not, I could never actually figure out, in my mind, in my personal opinion, was this an actual genetic thing, or were these late April and May sheep that more or less had went through summer months in Oklahoma and Texas and just hadn't done well, hadn't performed well. We all know coccidiosis can tear up one's stomach pretty fast, and their ability to convert and things like that can be skewed. So in my mind, I was always kind of curious, well, is this a thing? Is this certain genetics? Is this a nutritional deal, environmental, whatever it may be? So when I finally started getting these questions about 18 months ago, it kind of put everything in my head. And from hearing them talking about exactly what kind of sheep, how these sheep were coming out and what actually they grew like, and some of the genetics behind these sheep, it sounded like it was single gene recessive to me. Just from what I know, which is not very much, not near as much as the two men on each side of me know, but just in my mind, it kind of seemed like it might be something that's pretty simple to kind of figure out. So from there, I called Dr. Fitch one day and said, hey, what do you know about this? Have you ever seen any of these? What do you think it would take to actually figure this deal out?
Okay, with that, basically we had a pretty long conversation about it. I dealt with several other genetic situations back in the day with codon 171. We did a lot of the work here on that as far as doing some testing here with the spider syndrome way back in the day before most of you guys were born. But some of those kinds of things. So I think from here, we took it to Dr. Hagen, and Dr. Hagen got pretty excited about it, as excited as he can get, let's put it that way. And we started looking into it in more detail, and we put together a little PowerPoint here that basically he can explain his part, and then I'll try and give you some ideas as far as how to use this tool and those kinds of things. So let me see if I can get the PowerPoint up and rolling here, and then we should be good. Where's my mouse? Okay. Okay. If we're up there at this stage of the game, basically this is where we're at. With this, I'll turn it over to Darren and Hagen and let him start. Nope, this is you.
All right, so you go to the next slide, Fitch. So one of the first questions that we had here at OSU, at least in my lab, was what's the phenotype of the dwarfs? Got it. There you go. So what's the phenotype of the dwarfs? This actually really matters for us because any genetic analysis we do, we need to make sure that we understand the phenotype. And so here is a tested positive dwarf. On the left image, she's on the left. On this right image, she's in the middle. These are all approximately the same age. The two big ones are both clean, and the little one's a dwarf. Go to the next. And so a couple more images, same 3 sheet. We actually went out to a producer's place, identified a bunch we suspected were dwarf and a bunch we suspected were not. And I'm carefully saying not dwarf here on that bar graph, and that's because we didn't know if they were clean or carriers at the time. We did height measurements at...
They were a little over a year of age.
Okay. So
18 months of age.
At 18 months. And so one of the issues that we have in measuring heights of these individuals, and I think we're going to get some of this when we get to the questions, is there's a lot of variation in club lambs. Different operations are going after different traits. Some want more moderate sheep, and so we're doing measurements within certain individuals' farms, just to kind of eliminate some of those background genetics. And sure enough, we ended up with these individuals testing them later once we figured out what the dwarf gene was. And so the non-dwarfs are a mixture of carriers and cleans, and the dwarfs are in fact dwarfs. And you can see on this chart there is a statistical difference in height, so it's not just eyes deceiving us. The other thing that's interesting about this type of dwarfism is there's 2 types in humans and most animals. There's a disproportionate dwarfism, which is what we typically see in humans. So maybe they have a normal torso and head, but shortened arms and legs. And in these sheep, so far, we think that they're proportionate dwarfs, meaning that they have the same normal body plan, just shrunk down. And we think that that body is about 80–85% the normal height and normal weight of the non-dwarf sheep. And so really quickly, the next slide. So what we did, and somebody else asked a question already that I've seen, so to answer this real quick, there's a couple of ways that we can do this analysis. Historically, people have looked at doing SNP chips, and these are just looking at variation in genomes. And sometimes we know variants, we know places that genomes are different. It's not the gene that's causing the anomaly perhaps, but it's really close to it in the genome, and it acts as a good marker or measurement for that. In this case, we actually wanted to get to the variation that's really causing the dwarfism, and so we did what's called trio sequencing. And so you're looking at 2 pedigrees here, and on these 2 pedigrees, squares represent male, circles are female. The boxes that are filled in were dwarfs. Again, we relied on a couple of producers with a lot of experience in the sheep industry. They knew these were dwarfs. And so we sequenced their genomes, and then we sequenced the genomes of the parents. We sequenced these genomes roughly 30 times over, which means, we had between each family 90 genomes, and we actually did 3 different families. And so what we were looking for is anywhere in the genome that the dwarfs were exactly the same. And then we compared that back to the parents' genome and asked where they were different. Since the parents are not dwarfs, we figured they must be carriers, meaning if you think about it the way we have the test set up today, they would be FD and the dwarfs would be DD. And so we look through the genome, and suffice to say, out of 3.2 billion nucleotides in the genome, we were able to rather quickly identify the single base that's leading to the dwarfism. And so we're quite confident, we're very confident that we're correct on this. It's one of the very few, in fact, there's only 3 places in the whole genome where the dwarfs are always the same and the parents are always carriers. But the gene that we've identified as the dwarf gene, we know from human studies, there's human populations that have mutations in the same gene. Other animals suggest body size is related to this gene, and so we're quite confident that we're right on this.
So as we go further with this, based on everything that Dr. Hagen has done, we identified and all of the conversations we had with breeders, we were fairly sure it's a simple recessive condition. And once we understood that, and again, we're going right down the pack, same thing that Dr. Hagen said, once we knew that, it had to come from both parents. And that's a key because I've been getting a lot of phone calls from breeders throughout the US wanting to make sure that it's got to come through both parents. And that's key from the standpoint, as we look at basically a single gene pair like this, we have the same types of things when we looked at codon 171, which means you use a simple Punnett square. And just so you identify these or understand this, the nomenclature we came up with is FF is a clean pedigreed individual, all right, meaning free from the gene. A carrier is an FD, meaning that's got got the D in there, and then a double D is definitely a dwarf. And if you go back basically, and the reason I talk about this being similar to the codon 171, a lot of breeders have dealt with that and they understand the RR side of things, the QR side of things, and the QQ. Well, the genetics are identical to that from the standpoint, it's a simple Punnett square. It's basically, you're going to get one of those genes from each of the individuals, from the sire and from the dam. And so it's the easiest way to understand this. If you made these or used these tools, these breeding tools in the past on codon 171, there's not a lot of difference in how you make those decisions. And so 20 years ago, before we ever worried about having a dwarf gene or thought about it at all, basically we had clean rams bred to clean ewes. And if you have that, you have 100% of those lambs are going to be clean. They're going to be free from, not only free from the dwarfism, but not carry that D at all. And so most other breeds, this is where we sit out there at this stage of the game. Now, when we start talking about dwarfism and carriers, this is where I think this is a tremendous breeding tool, and that's what we want to get out there. Is this is a great breeding tool for you to make breeding decisions on what type of lambs you want born. FD is a carrier, so if you take a carrier ram and you breed to carrier ewes, I want you to understand the percentages here. If you look at the boxes, basically you've got an FD across the top, you've got an FD along the side. This is what we call a regular Punnett square. And if you look at how those genes are passed, you're going to end up with 25% clean, or FF, 50% carriers, or FD, and 25% dwarfs when you do a carrier to a carrier. Now, I want to clarify a couple things. We say that you're going to end up with 25, 50, and 25, but I think we all understand when you have ewe lambs and buck lambs born every year, it's not 50-50. You could have 60% buck lambs one year and 40% ewe lambs, and the very next year you could have just the opposite. So these are what you should get. These are approximations. And as you breed those individuals, if you're breeding carriers of carriers, you expect about 25% dwarfs. All right. You also expect about 25% FF. And this is, again, another thing that I've talked to a lot of breeders about is that, okay, we want to potentially move away from having those carriers as part of our bloodlines. Well, one of the things that I want to make very clear, and that is, do not just get rid of everything just because they're a carrier. At this stage, those carriers are extremely valuable. They're very good individuals, and you breed carriers to carriers, as we show here, 25% of those lambs are going to be clean. So you're able to keep a lot of those genetics, that bloodlines that you have selected over the years and want to keep that in there. You can slowly move away from that, even if you have a lot of carriers in your flock. So the next one here, and I put this up here both ways just so you can understand this, is if I've got, and if we've got a dwarf ram that we want to use out there and really, really like that individual and want to keep him around and breed him, there is no reason you can't breed him to all of your FFUs or your clean ewes, or you have a clean ram bred to dwarf ewes. And if you do that and you handle it that way, 100% of those lambs are going to be carriers. There is not going to be a single dwarf born as long as you make sure you breed that DD ram to clean ewes. Okay? So just an understanding, and it's, again, that's a really, really good breeding tool to understand how to basically minimize the number of dwarfs that you've got out there. And lastly here, if you want to make sure that you don't have any dwarfs at all, then, and you've got a group of carrier ewes out there, or you don't know what you've got, you just know that you have a group of ewes out there, and maybe in the last year or two you've had 1 or 2 dwarfs, so you might have some ewes out there that are carriers. Breeding those individuals to a clean ram, as you can see by the Punnett square, you're not going to get any dwarfs at all. You're going to get 50% clean and 50% carriers. And that's considering that all of your ewes are carriers. And in most of our operations out there, we may have a few that are carriers, we have a lot that are clean, but the bare minimum you're going to get is 50% clean ones here and 50% or less carriers, depending upon how you're breeding those. So to end that part, we talked about it being a simple recessive. We talked about this being both parents have to be involved here. Both parents, in order to get a dwarf, have to be carriers. And at this stage of the game, I think you all know this, we've got testing available. Gene Check is testing these individuals at this stage of the game. And I called Tressa and talked a little bit about it now. Or talked about it this morning and looked over, asked her to send me numbers. Oops, and I guess I don't have those in here. But basically, her numbers are about 1,900 plus that are clean, 1,850 that are carriers, and about 170 that are dwarfs as of today.
And then, while I've got a captive audience, I wanted to advertise something that several of us are starting or have started. We hear stories today that individuals knew this dwarfism was popping up as early as 2012, and probably even before that. Nobody was looking into it. And the reality is sometimes something is born at your place and it's different, it's anomalous, and you look at it and you say, hey, that's weird, that's something different, and you move on. It's only when we start seeing some of these things more frequently that we start asking if this is a bigger problem. And so Jolena Waddell at Tarleton State University in Texas, Tasia Taxis at Michigan State, and then myself here at Darren Hagen here at Oklahoma State. And this is the project led by Jolena Waddell. We're starting the National Sheep and Goat Defect Registry, and the idea is that if you've got something born on your place, or you know of something born, if you could send us some blood, tissue sample, whatever, something we can get DNA out of. If you would email one of us and let us know what you've got, get it, throw it in the freezer, and we'll tell you how to get it to us. You send it to us, we'll throw it in our freezer for long-term storage. And ultimately, we'll ask you information about what this individual had, what it looked like, pictures if you've got it. And once we hit some critical mass of these defects, then we can go in right away and start sequencing. This is something the cattle industry's had for a while, but for sheep and goat producers, we've not. And so the three of us are starting it again. You can do it by general region, or you can reach out to any of us. We can share more information.
Okay, so at this stage of the game, we've had a few questions that have been sent in. It's not. It should have gone off. We're back on.
Are you sure? No, it's not off yet.
Whoa.
I can read some of them to you if you'd like.
Is PowerPoint still up, Stephen?
No, it's down.
Okay.
Do you see that this is more prevalent in blackface weather type sheep, or do you also see it in other breeds such as Dorsets, Southdowns, etc.?
No.
I think at this stage of the game, we have seen it basically in blackface sheep, in the clubline blackface sheep. I don't know that we can talk about it in any other breeds at this stage of the game. However, one thing you have to realize is we get such as speckles and some of those kinds of things, as we get the blackface moved over into other breeds or other genetics, then definitely could come up there. But at this stage of the game, I think right now, all we've seen it is in the blackface sheep and almost exclusively in the clubline sheep.
So can I elaborate on that real fast? I've had a couple people ask me, blackface, whiteface, whatever kind of sheep, but the question that I've had is this dwarfism present in, either Dorset sheep or Southdown sheep or whatever it may be? So it wouldn't be the same dwarfism. That mutation, this is where I was going to point to you at, that same mutation would be highly unlikely in a different breed of sheep without having a blackface sheep in the background of that certain sheep.
Yeah, so this mutation is rare. It probably started with one individual, who knows when. That individual was bred often. His or her offspring were bred often, and that's how we got it. So what ultimately gets us to where we are today is the abundant or prolific use of line breeding. So one individual's got characteristics we like, and we keep breeding back into those genetics. It's a reality of livestock production. All livestock breeds suffer from this to some extent. If you see dwarfism in other breeds of sheep that were not crossed with a blackface individual like Darren is suggesting, this dwarfism test wouldn't work, or it would be super unlikely to work, and that's because it's a rare mutation. And if there's dwarfism in other breeds of sheep, it's probably due to different mutations. Or, even if it's the same gene that's mutated, we found a single base, a single bit of DNA, and even if it's the same gene, it would probably be a slightly different version of that same gene. And so this test wouldn't work for that.
Okay. This next question comes from California. Are we able to test animals that are deceased based off of a previous result submission?
As far as gene check, having that tissue stored or blood stored, I believe so. From what I've heard, if you have sent samples into gene check, they store those samples. Now, how long, I do not know. But as long as you have sent something to gene check in the past for spider or scrapie, I believe you can call and ask them to pull that sample and test it for the dwarfism gene.
That would definitely be a question for Tressa and Bob at Gene Check.
We need to make sure that's correct.
Okay. The next question, let me get back to it quick here, is from Texas. Do all animals testing DD have to show the phenotypic changes associated with dwarfism?
I would say definitely. Now, do we see variations in dwarfism? I think also, most definitely. You're going to have individuals, and again, where we're getting a lot of this information is from breeders that we've talked to and some that we've seen and those kinds of things. But there are a lot of these lambs that are born as dwarfs will have ligament problems and will have feet and leg problems where they've got to stretch those out. But there are others that are born completely normal. And we've also seen, and this is where I want to make sure I clarify this, we've seen individuals that have been extremely competitive in the show ring in the lightweight classes that are dwarfs and extremely competitive. I can almost guarantee that 3 of the top 5 at OYE this last spring in the crossbred division were dwarfs. And so they fit very well into the lightweight classes. Is there a lot of variation? Most definitely. Is there definite differences in size? Yes, I think so. And that's why I don't think at this stage of the game that we can even make a good guess as to whether an individual is a carrier or clean. And I'm not even real comfortable calling an individual a dwarf unless we go ahead and check him, unless he's super small and has all those characteristics. If you're a bigger framed potential dwarf, I think you need to get him checked, because we've had some producers say, well, I thought this was a dwarf and he ends up being a carrier. So I think in all cases, the best case scenario in this scenario is to get them checked.
So it goes back a little bit to what Dr. Fitch talked about before, and kind of what we've tried to tell people is everybody's got different genetic bases, correct? So even though our gene pool is actually really, really small in the club lamb industry, people have different genetics that they like, and they roll with that. And like Dr. Hagen said, they line breed quite a bit. So a dwarf at my house, a dwarf at the Oklahoma State Sheep and Goat Center, and a dwarf at whoever's house, those are going to look different throughout flocks. So even though we can guess and maybe try to tie some of these, phenotypic traits that we've seen, not all sheep are created equal. So more or less, they can express different characteristics from flock to flock, and that's kind of what we've heard. And that's been the story so far.
I want to add just really quickly. So, the question was about exhibiting the phenotype. One of the issues we have is we've not really identified a phenotype yet. I mean, there's characteristics that some of these dwarfs have, but then we've seen dwarfs that are completely free of some. I mean, for every 1 or 2 where that front leg or those tendons are tight and it's bucked over a little bit, there's plenty of them that seem to not have that issue. And so I think it's, I would prefer to be a little bit more conservative and not necessarily talk about these other traits that we're seeing, because, safe money would say that those are associated with the dwarfism, but the dwarfs have it, but not all the dwarfs have it. And to be honest, we don't even know percentages for that. Great.
Okay, there's been some other questions come in that we got in the last day or so. So I'll go ahead and go through those. One of the questions that came in is, what is the likelihood of another dwarf gene already out there in the population, one that doesn't show up under this testing?
Who knows? I mean, an honest answer, who knows? It's,
What's the likelihood of another dwarf gene, though? I mean, it's minuscule.
I mean, it's small, but yeah, sure. In other breeds, so if you see dwarfs in any other breeds, of sheep, if you see dwarf in goats, Angus cattle, for instance, those typically they're always a different gene. So, and in terms of black-faced club lambs being dwarfs, it's probably, right at 0, real close to 0.
Okay, I've got another question that was sent in the last day or so. With the current work being completed across many species on a variety of issues, i.e. PRRS resistance in swine, using gene editing and CRISPR-9 technology, has there been any work to discover the gene coding for dwarfism? And has there been any work completed using gene editing to solve this issue?
So no, there's several reasons why we wouldn't necessarily do this in sheep. So all swine in the American swine industry and pretty much actually worldwide are susceptible to something like PRRS. It's a virus, the pigs get sick. That mutation that keeps them resistant to PRRS was found in some wild African pig, and they moved it into common, to swine here in North America. The real problem becomes, and this is actually where listeners can help us out. So in the United States, genetically altered livestock, genetically altered animals fall under the purview of the FDA, the Food and Drug Administration. This goes back to the 1930-somethings when the FDA kind of helped control food. And in the 80s, they decided that any genetically modified animals would fall under drugs. And today, the technology today, we can change a single base. And so if you think about dwarfism, out of 3.2 billion bases, it's only one that causes dwarfism. We could revert that back, but the FDA controls it. Ironically, crops in the United States are controlled by USDA. USDA has somewhat said, yeah, you can do genome editing on crops and it's no big deal. So in the laboratory, we could do this and we could fix the dwarfism. It'd be an interesting experiment to do. There's no reason to do it for club lambs. You guys can just breed that, make breeding decisions, but you also wouldn't be able to sell that individual or any of its offspring to, for future food production. So it's kind of a non-starter because you'd have these corrected sheep that you would just look at and not be able to do anything with.
Okay, we've got another one, and I think we've pretty much answered this question, but I'll throw it out there because it was asked. Dwarfism has become a bigger and bigger problem in my flock over the last 3 years. How can I fix this problem? I think the easiest answer there is use and talk about the breeding schemes that we talked about. If you are having a major problem, then the use of clean rams is a definite possibility. If you check all the ewes and you've got carrier ewes out there and you don't want to get any dwarfs at all, then yes, you're going to have to breed to a clean individual. And that being said, if you test all your ewes and you have a group of clean ewes out there, there's no reason you can't use a carrier ram on those and still not have any dwarfs. I think that's just one of those questions. Another question, how much variation exists within carriers? I don't know that we have the answer to that. I think that's future research, and it's some of the things we've talked about here as far as expanding some of the research and going out and trying to identify and measure individuals as they grow and see how much variation is out there. I think just like we see a lot of variation within different flocks or across flocks, I think we probably have those same types of variation when it comes to carriers versus clean individuals. You want to add to that? Okay. All right. Are all FDs created equal? In other words, is it a simple 2x2 grid, or some carriers, FDs, hotter than others? You'll go? Let me go?
Yeah, we already showed that. Yeah. So the answer is yes, they're more or less created equal when thinking about the genetics. We looked at sex. There's no differences in sex. So if the buck is a carrier or the ewe is a carrier, there's no difference. They're born equally, 50-50, male, female. So I would say genetically, yeah, it's just the traditional 2x2 Punnett square that Fitch was showing earlier. And that it makes it really simple to make your breeding decisions.
Yeah. I don't think it's any difference than when we talk about the other genetic abnormalities that we've talked about. It's the same kind of things. They're not, in talking about those individuals being hotter than others. It's just like male and female. You may have more ewe lambs one year than buck lambs and switch around the next year. So I don't think we see any differences there. Another question I've got is, what is going on with dwarfs? Why do they grow to a point and then just tail off? I think the easiest answer to that is they are an early maturing individual, and if you know anything about growth curves at all, they're going to grow to a certain point. Later maturing individuals are going to keep growing at a longer level and stay longer. Moderate are going to be somewhere in between, and then what we're seeing is decent growth to a point, and these sheep are maturing very, very early, and therefore their growth curve is leveling off. Oh, good. All right. Is there, last question I've got on here, Stevie, you might have some others now. Is there a relationship between being a carrier, FD, and having additional muscle shape?
We don't know. That's some of the stuff that we've talked about looking into in much more depth and much more research-minded people like the two individuals on each side of me can do a lot of things with that over the next year. The muscle shape thing is something we've talked about. I don't know, you want me to talk about this? So in a dwarfism, so obviously the sheep's going to be smaller. Is there actually a relationship to muscle shape, which producers like myself, like I get it, I understand where that question's coming from, but is the actual muscle fiber actually bigger in diameter? Is it because that muscle is laid on a skeleton that is much shorter and more compact, therefore visual would look bigger, okay? Phenotype, these are a lot of the questions that I've got. So is there certain characteristics tied to carriers or dwarfs that we've found and we've identified? So Dr. Hagen's actually said this in one of our conversations. There's been something about them that we've picked. I mean, obviously we've compounded the problem, therefore we have started to get more and more of them. So there's something about carriers that we like. What that is, we don't know. I don't. In my personal flock, and even in Oklahoma State, I haven't seen anything whatsoever that you can actually guess, like Dr. Fish talked about, and I think it is a guess, that you can guess which ones are FF, which ones are FD, and now the DDs are ones that you can probably more closely identify, but trying to guess FFs from FDs, I don't think you're really kind of wasting your time. You might be able to get within 75%. That's kind of where I've been about on the sheep that I've tested, just because I've been a part of this thing and being able to test sheep now. I've looked at them before I've sent blood in, like, okay, this one's FF, this one's FD, so on and so forth. I get the test back. I'm about 70%. So take that for what it's worth, but it's a guess.
Yeah, I think at least Darren and I have talked to a lot of breeders in the last 6 weeks about this, and many of them are surprised when they get their blood work back. They thought, as they look at their individuals and they're trying to go ahead and guesstimate what they are before they send the blood in, and they think this one's got more mass and more muscle, and he ends up being FF, and they think this other one's got more, isn't as thick, and ends up being a carrier. So at this stage of the game, I think it's an educated guess, but I don't know if we can do that at all. And I think we have to do a lot more research and figure that out. At this stage, I don't know if there is or is not a tie to whether they're a carrier or not. I think there's definitely a tie to the genetics that are behind them. And so it may be more of a selection on those individuals that have more thickness and more mass than it has anything to do with being tied to the dwarf gene at all. Steve, have you got any more questions, or do you have any more come in?
I've had some come in, but there are a lot of duplicates or ones we've already covered. So I think with that, we can go ahead and end this. We want to thank you guys, all three of you, for joining us tonight, as well as Purina and Clay Elliott for helping us organize this. Once again, thanks to everyone for tuning in, and we really appreciate it. And there will be a second part to this that Purina will be doing at the Midwest Stud Ram sale. And you can watch for more information on that coming out in the next few days. So thanks again, and hope everyone has a good night.
We want to make sure we thank Champion Drive and Purina for this too. I think it's an important issue that we get out to the clubland producers.
Great. Thank you.